Okay, so we're looking at the code, right? The variable is the counter. The function, which is going to be repeating, is called draw. Background is white. Text size is counter, right? Counter is the variable. So the text is going to start, the text counter is going to start at 0 and 400. So that would be like right here-ish. Counter equals counter plus 1, right? So that means it's going to go plus 1 every single time, right? Counter plus 1. Here we go. And there it is. It's going up 1 every single time. Not just in actual numbers, but in size as well. Alright, so they want us to move this little plane over. Nice, right? So let's go back to our previous lesson. And that gives you the answer, right? Counter equals counter plus 1. That's what we did for this one. So now let's go to this lesson. And instead of calling it counter, it's called plain.x, right? So we'll type in, well, let's run it first. Error line 8, which is here. So we're going to go plain x. Plain.x equals plus 1, right? Because we want it to go move 1 every single time in the loop, right? Plain.x equals plain.x plus 1. That's the variable. It's going to be going a loop, so it's going to go again and again and again. Let's check it out. And there we go. So again, plain.x equals plain.x plus 1, just like we did in lesson 3, or part 3. Alright, lesson 5 builds off of number 4, right? So we're going to move the fly to the left instead of to the right. So remember, we went plus to go right, so we're going to go minus to go left. Let's see what we have so far. Just a fly. So we want to add our variable into our loop, right? And we want our math, because it's going to go plus 1, right, to move. So our x is the fly, right? So fly dot x, right? Just like we did in lesson 4, it was plain dot x equals plain dot x plus 1. So this one, we're going to go fly dot x equals fly dot x plus minus 1, right? Let's check it out. There it is. Now, if we wanted to mess around, we could go minus 5, and we just go faster. $10. We did it. Okay. It says, read the program and predict which of the following animations will be produced. Okay, so the easiest thing to do would be look at our variables, Variable green car. Create sprite. So it's going to be created on the 150, 450 line. And of course, 150 is our X, so left to right. And our Y is 450, up and down. So let's check it out. 150 by 400 is right here, right? So our green car is starting at the 150 mark. So this one's not it. This one's not it. This one looks like it's it. Let's see. And it is. The answer was C, right? Because the green car was starting right here. Awesome. Okay, so we want our little mouse to go at a diagonal. Anyway, we want it to go at a diagonal movement. So to do this, first we'll run the code, and we see that it's going up and down, right? And when we look on our pattern, our loop, it says function mouse y-axis +2, right? Up and down is the y-axis. So what we need to do is add the x-axis, right? So each time it's going to move down 2, but then it's also going to move over 2, right? So let's go to our variables. Drop it in. Oh, not this one. This one. Our sprite. And we have y. We want to do x, right? Because we have the y here. So sprite. Drop it in there. The sprite is the mouse, right? Equals, once again, drop it in there. Oh, we need to add our math first, plus, and we'll get our variables and our sprites. Drop it in, mouse. So mouse y equals mouse y +2. So it's going to go a movement of 2 every time this way. And then mouse x +2 means it's going to go over 2 each time this way. So when it goes down 2 and over 2, it's going to be at this spot, right? Down 2, over 2. So it's going to go to diagonal. Let's check it out. Nice. Okay, now we have to fix the rotation, and we are set. Alright, so let's find the rotation. Where is it? There it is. Okay, sprite rotation. Drop it in. Let's check it out. Mouse, because we have to name it so it's got to all match up. Mouse rotation equals, I don't know, let's take a guess. 50? Reset, run it. Okay, 50 is not the business, obviously. How about 250? No. 350? Well, it's looking better. 320? Oh, that's nice. There we go. So remember, all this has to match up. Y-axis, up and down. X-axis, left to right. Together, it's going to go down 2 over 2, so it makes it look like it's going at the perfect angle. And we're rotating. Good job. Let's on to the next one. All right, let's check out what they're asking. Read the program, predict what the program will do. Run the program, check the prediction. Okay, the variable is the pan, right? It's a sprite called pan. Background is green. The pan is rotating 1 each time, right? Just like we did with the mouse moving, instead of going forward, it's just going to rotate 1. So I'm going to say spinning pan. Yep, spinning pan. It's very exciting. On to the next one. Alright, what's up with this thing? We've got a motorcycle that's going from corner to corner. Right? Nice. Let's run it and see what we have. Alright, it's just dumping right here. So let's look at our code. Variable cycle, blah blah blah. It's rotated going this way. Okay, background light gray, that's good. Cycle x equals cycle x plus 10. So that would mean that the x coordinate is going over 10, and the y coordinate would be going down 10, right? Down. And we don't want it to go down, because when we run it, it's going down. So let's change this to minus, right? So instead of going down, it's going to be going up. Because when you look on the grid, right, like right here, we're at Y300. And if I keep going down, I'm adding more. So if I wanted to go this way, I would have to go up. So it'd be minus, right? So let's see what we got. And we've got it. If we wanted to go slower, again, we can just knock it down 5. Minus 5. And run it just a little bit slower. Right? So what we're saying is we want this y position to be at minus y, because we want it to be going this way, up, not down.